Energy is a really important area. We use it all the time. It's part of our daily lives. It's something we consume. Before we've woken up, our gas boiler in the UK has set off going, so we have nice warm water and we can shower and our houses are warm. We boil our kettles, we're charging our phones, we're listening to the radio. But when we have a lack of energy, when we have a lack of access to that energy, it's very, very difficult to comprehend sometimes, and it's very, very difficult to live a good quality of life without access to energy. And so the Sustainable Development Goals, given by the United Nations in 2015, goal number 7 said access to affordable, reliable, sustainable energy for all. And this is something that we're really interested here in Bristol, looking at how we can research and how we can enable this to happen. Within the Sustainable Development Goals, there are different targets, but we can enable that through new technologies. We can also enable that through capacity building and supporting different communities to be able to understand and be able to develop their own in-house technology, and to be able to use technology that they were using in one way in a different way as well, to be able to support their lives. The other thing to realise is that energy doesn't just support one sustainable development goal. The other 16 development goals, energy is key to most of them. If you think about reducing poverty and zero hunger, access to quality education and good healthcare, energy is required for all of these. And so energy is a real key player in trying to support sustainable international development. Cooking is one of the most important things we do with energy. It gives us our energy to do the things that we want to do, and it consumes a lot of power. And so quite often people use biomass, especially in developing countries, to cook. And in Nepal, 70 to 75% of the population do this. But if we can displace that with electricity, they have much better access to clean cooking facilities. It doesn't affect their health as much. But the problems around this are being able to actually support that large power requirement over a very short period of time when everybody is doing the same thing, and there are real challenges around that. And so we're looking at, especially off-grid systems where you are very capacity constrained, how you can support electric cooking in those situations.
So why electric cooking? Well, 3 billion people around the world still cook with biomass, and in Nepal 70% of the population cooks with biomass, which is generally firewood. And that produces harmful emissions. So in Nepal alone, 20,000 people a year die from conditions associated with indoor air pollution caused by cooking with firewood. People in rural Nepal regularly spend hours travelling, sometimes long distances, to collect firewood. When I was in a rural village called Salyan in eastern Nepal recently, an elderly lady showed us how she regularly carries 30 kilograms of wood on her back, collecting firewood for cooking. Electric cooking is a clean alternative to biomass cooking, and it frees up people's time for things like work, education, or just doing what they want, more leisure time. But introducing a new technology like electric cooking to a community that hasn't seen it before is not straightforward. It's very much a socio-technical problem. On the technical side, everyone wants to cook at the same time, but in these off-grid situations, micro-hydro mini-grids, there's a constrained amount of power. So we need to look at solutions. Solutions like scheduling of cooking. Can households schedule their cooking to reduce that peak demand? Or storing the power, so storing power during off-peak times so that it can be used during those cooking times. Or perhaps more efficient cooking devices are needed. Even if the technical problems can be solved, cooking is a deeply cultural experience, so the social aspect is very important. Unless an electric stove can fit with existing cooking practices and traditions, it might not be used at all. I've been involved in 2 projects investigating both the technical and social side of this problem. These projects have seen 25 induction hobs and rice cookers provided to households in rural villages in Nepal. As well as those technical work packages, I've worked a lot on researching the social aspect of a transition to a new technology like electric cooking. As for what's next in my PhD, a potential solution is to explore more efficient electric stoves like electric pressure cookers, which can run on lower power. So those devices could enable more households in a constrained grid to cook with electricity. I became interested in doing this PhD during my final year project, which focused on developing modular electrical devices for bread making for the developing world. During that, I met my supervisor and discussed his work in Nepal and his interest in engineering for development. And it became clear to me that engineering skills can be used in developing countries to have a significant impact to people's quality of life. And that's what really attracted me to working in this field of engineering for development.
I did an undergraduate degree in mechanical engineering at the University of Bristol, and in my final year I had a project which was looking at the local manufacture of small-scale hydropower systems, specifically very small pico-hydro, so enough to generate enough electricity for a few homes. And during my engineering degree, this was my first opportunity to see how engineering could really have an impact on people's lives. And I was inspired by that, and so when I finished my degree, I went and volunteered in Nepal for 9 months. After around a year, I decided that I wanted to combine these two experiences in order to research how the sustainability of hydropower systems in Nepal could be improved. And so my research area is trying to understand how the sustainability and reliability of micro hydropower plants in Nepal can be improved. So in Nepal, the geography is very well suited to hydropower. It's very mountainous and there's lots of water, and those are the two things that you need to generate electricity. The problem in Nepal is that over the last 20 years there's been a lot of political instability, and combined with the difficulty in expanding the national grid in the mountainous regions, it's meant that there's lots of communities which don't receive electricity from the national grid. Instead, because of their geography, they are well suited to small-scale hydropower systems. And so what happens is you'll have a river, some of the water will be diverted, it goes through civil works, down a penstock pipe, and rotates a turbine which is connected to a generator. These systems are manufactured locally in Nepal, and then typically the community will assist during the construction of the civil works, and then will become responsible for the operation and management of the system once it's installed. In order to do this, we've worked a lot in collaboration with the NGO I originally volunteered with. This NGO is called PEDA, the People, Energy, Environment and Development Association. And so, together with them, we went and visited 24 micro hydropower sites in a rural area of Nepal. Through another project, we have also worked with a local manufacturer to investigate installing a new type of turbine to Nepal. This type of turbine is well suited to Nepal as it is good at dealing with silt, which is often found in the rivers of Nepal. Through this project, we wanted to understand whether it's possible with the local manufacturing capability to make the turbine and install it in Nepal. We learned that the problems that affect micro hydropower plants are often diverse. It's not just simply a case of whether the technology works well or not. Around the technology itself, there's also a socio-technical system. So there are people who rely on the electricity, and they need to make a financial contribution in order for the system to work. When technology is installed in a country like Nepal, there needs to be a much wider consideration of the context around that technology. One cannot just expect that it will be installed and then it will work. So with our second project, we're hoping to explore how a new technology can be implemented in Nepal. And so in order to do that, we've had to develop an understanding of what the manufacturers are capable of and then what they can produce as a final design. We're hoping to validate the results of our new turbine by testing in a lab at Kathmandu University. In a traditional engineering problem, often people are forgotten. But when designing for the developing world, one needs to consider the restrictions in terms of materials, in terms of the environment, and how the technology will actually be used by people. I think it gives engineers an opportunity to implement technology that really can make a difference to people's lives. In my opinion, engineering in this context isn't just about torque and stress, but it's also about people and culture.
Engineering and international development is not just a single discipline study. You actually have to be aware of all the other disciplines going around it. It's a very social, very cultural based application, but it's also, you have to be aware of policy, you have to be aware of economics, and you have to be very much be able to interact with different people across the world, and that is really key to be able to make successful engineering and international development projects. There are lots of different groups that work in engineering and international development. For example, the Low Carbon Energy for Development Network, based out of Loughborough University and Durham University. There's a bit wider, there's Engineers Without Borders UK, which are part of Engineers Without Borders, the global organisation as well. So why do we need to do this engineering and international development, especially in energy? Well, we all know the climate crisis is here and is hitting us, and energy is one of the big things that we need to do to be able to solve this. Developing countries' populations are growing rapidly, and we need to be able to, or they need to be able to, be on a different track that we were as we were developing. And so we need to be able to support them in this, in a low carbon generation of power, low carbon use of power and energy, and be able to support their economies to grow without consuming the same amount of carbon, without creating the same amount of waste that we did. And that's why it's really critical for us to do that now. If you are interested in engineering and international development, do also go and talk to academics that are interested in this. So they could be, again, in your faculty, or they could be across the university. And there are different research groups in different areas that do work in this, in international development. So don't be afraid to go and ask questions and speak to them. Everyone loves talking about their research.